Today we are going to learn some basics for our language. Before we go further, let's see what a programming language is. You see, when we talk to each other, we often communicate in several languages like English, Hindi, French, Korean, etc. When we communicate with a computer, the language we use is known as programming language such as C++, Python. Our language was actually created for data analysis by Robert Gentleman and Ross E. Haka. Like any other language, it has a few basics to learn. Today we will talk about data types and data structures. Let's start with data types. You remember how we were taught alphabets and numbers when we were small. These are what is referred to as data types. There is numerical data type. As the name suggests, it consists of numbers. Character data type, also called string, which consists of alphabets and numbers. Remember, this data type always has quotes on both ends. The third data type is logical data type, which has only two values, true and false. Let's cover these data types in brief. Numerical data types is further categorized into numeric like 49, 1.5, integers which end with a capital L such as 45L, 69L, and complex numbers like 3 plus I, 10I and so on. Mathematical operators are used on this data type such as addition, subtraction, multiplication, division, exponential, etc. Now let's see character data type. As I have mentioned before, this data type has quotes on its both ends. It can be double quotes on both ends or single quotes. But two different kind of quotes on both ends are not accepted, such as single quote on one end and double quote on the other end. It will give error. In character data type, numbers can also be included. For example, 45 is a number and is considered as numerical data type, but when the same 45 is in quotes, then it is considered as character data type and not numerical data type. Since 45 in quotes is not a numerical data type, therefore mathematical functions cannot be performed on it. Addition of 45 in quotes to 49 will give error. An interesting feature of this data type is locational indexing. Whenever you enter a character, each letter is given a locational index. For illustration, let's consider the data hi, how are you? Every character including alphabets, comma, and question mark will be given a location number sequentially. Even spaces have been assigned with numbers, that is, 7 and 11. If you will ask the location of W in this data, it will answer 6. Now for the logical data type. This data type has only two values, true and false, which are also known as Boolean values. It can be used with comparison, also known as relational operators such as greater than, less than, greater than or equal to, less than or equal to, not equal to. Pay attention that the sign of equal to is not a single equal to sign, but a double equal to. That is because single equal to sign is already reserved as assignment operator, which we will talk about later. Logical data type is also used with logical, also called as Boolean operators such as and, or and not. And operator will only result in true if both statements are true. For example, here one statement is false and other is true, then it will give the answer false. If both statements are false, then also it will give false. Only when both statements are true, then it will give true. Whereas in OR operator, even if one statement is false and other is true, then also it will give true. In case of OR operator also, if both statements are false, then it will give false, and if both statements are true, then it will give true. In case of NOT operator, it will give true only if statement is false. For example, the statement 45 greater than 49 results in false, but if there is NOT operator before that, then the answer false will convert into true. Now let's discuss data structures. These are structures derived from data types. The first one is vector. Vector is a list of items where every item belongs to the same data type. To create a vector, make a list of items with similar data types in parentheses and array C before it. Notice here that for character data type, each item is present in quotes. Another way is to use colon. It represents range. Such as 5:10 will give the numbers 5, 6, 7, 8, 9, 10. Each item is also given a location index. If you will ask which item is present at position 2, then it will give the result CD. Remember to ask the position. Use square brackets and not the normal parentheses. Similar to vector, there is another data structure called as list. The only difference is the items in it can belong to different data types. One can create a list by making a list of items in parentheses and adding list before it. Similar to vector, each item here is also given a location index. For example, PQ of 5 will give 6i. Another data structure is matrix. Matrix is a list of items where every item belongs to the same data type and the items are distributed into rows and columns. To create a matrix, write matrix and within parentheses, mention the items, number of rows and columns. In matrix, the locational index of items are defined by both rows and columns. So to find an item, mention the variable and type row first followed by column number in square brackets. For example, SRT and within brackets 2 and 3 will give the item at row 2 and column 3, that is F. If you want to select the entire row, then leave the space for column empty, such as SRT2, empty space, and it will give the second row D, E, F. Similarly, to select a particular column, leave the space for row empty, such as SRT empty space 2, and it will give the second column B, E, H. A similar data structure is array, which has more than one matrix. To create an array, write array and within parentheses, mention the items. After that, write dim and mention the number of rows, columns as well as matrices. The locational index of items in array are defined by rows, columns and matrices. For example, MPS and within brackets 2, 3, 2 will give the item at row 2, column 3 and matrix 2, that is 15. To select the whole row, then leave the space for column empty just like that of the matrix, such as MPS2, empty space and 1. It will give the whole row in matrix 1, that is 4, 5, 6. Similarly, to select a whole matrix, leave the space for both row and column empty, such as MPS, empty spaces, and 2 will give matrix 2. Data frame is one of the most used data structures you will come across since it is used in Excel sheets. Here data is presented in a tabular form and can have multiple data types, but each column can have only one data type, and each column should have a header like name, weight, etc. In the data frame, we have character data type in name column, numerical data type in weight column, and logical data type in married column. To create a data frame, write data.frame and within parentheses, mention the column name and with it write the vector that contains items for that column. For example, for name column you will mention the vector containing the names Avinash, Jaya and Pradeep. Similarly, you will mention the vectors for weight and married columns. To find an item in the data frame, you have to mention the row and column number just like that of the matrix. You can also select a column by mentioning variable name, adding a $sign to it, and then writing the column name such as AM8 $weight. This will give the values of the weight column. If you want to select first rows, then also you can mention the range of rows. Such 1:2 and an empty space for column will give you entire first rows. The last data structure is factor. It consists of items that specify categories. For example, high and low, male and female, yes and no, etc. These categories are also referred to as levels. To create a factor, make the list of items in parentheses and add factor before it. If you will ask the levels of that factor, then it will give the specific categories instead of the whole data. By default, R assumes a particular order of the categories. In case you want to change the order, then mention it during the creation of the factor. For example, in variable M7P, we didn't mention the order. The levels in M7P automatically have female category mentioned first followed by male category. But in MP4 we mentioned the order. The levels in MP4 now have male category mentioned first followed by female category. In addition to this, we can find the locational index of the items just as we did in vectors such as MP4 will result in female. That's it for this video. Thanks for watching.